All right, 10-2. I don't think this section has a ton in it. It's kind of just like a little step past what we did for functions. We're going to come back to that in a second. But first, we have this word linear here. And if you look at the word linear, there's a whole bunch of words, including the word ear. There's ear. There's line. There's near. Already have ear. No, just looking at linear. In. If you're a pirate, you'd see the word R. Or the two single letter words A and I. Okay, but we're talking about the line. So linear functions are going to be things that are a straight line. Yes. So that's part of it. That's the linear part. Anything that's linear has to be a straight line. But a function, if we go back to yesterday's section, or 10-1 at least, maybe not yesterday, but it says functions each x can only have one y, right? So if we're talking about straight lines, and I'm just going to try to draw a graph here. I don't know if I'd bother with you, but what kind of straight line could I draw on that graph that has an x value that has more than one y value? What does the line have to look like if an x value has more than one y value? Go for it.
Horizontal or vertical?
One of the two. Horizontal or vertical?
Horizontal.
Vertical. Because if I were taken to a vertical line, or at least my attempt at a vertical line, do you agree we could pick and maybe say the x value right here is, I don't know, 3 or something? Pick some x value. So that's going to be 3, 0. If that line is truly vertical, here I'm going to have a point that's 3, I don't know, 3, 3. 3, 4, 3, 7. But we're going to have on there, we're going to have points that all have an x value of 3, but they're going to have different y values. Fair enough? So when we talk about a linear function, we need linear, a straight line, and a function, it's not vertical. So a linear function is a straight line that's not vertical. Good? So this section only has like a couple little tidbits in it. That's going to kind of be one of the tidbits. Talking about linear functions, straight lines are not vertical. Now if we have a graph, we have the x-axis down here. So this is another thing in the section, the y-axis up there. Now in science class, math classes, we talk about dependent and independent variables. Where does the dependent variable go? Is that the y or the x value?
X. Y.
The y. So dependent. So the dependent variable is going to be the y. Maybe we'll write in variable. And the independent is going to be the x. So, and if you think about that, usually when we write an equation, it's going to be y equals something with an x in it. It's more common to say like y equals 3x plus 4 or something like that. But we'll take and we'll have the dependent variable off by itself. And then the independent is going to be sandwiched in with a bunch of numbers. But it'll be solved for the dependent variable. And just kind of an extra little tidbit. If you have time ever, time typically is going to be an independent variable. Things depend on time. If you look at the temperature in a room compared to time, well, if you put a bunch of people in a room, the temperature will go up as time goes on. So temperature dependent.
Like the concert.
Like the concert last night, yes. Got warm, but only one person fainted, and that was really a highlight of the concert for me. Seeing Mrs. Wagner walk over and grab him and kind of help him down and go back and keep directing. It was beautiful. It was beautiful. So, okay. All right. Back on track. So to this last little section, the book gives some examples or some questions like this. So I figured just quick go over it because I confused people one year. But we were talking about how the input, this here is kind of like the independent. You don't necessarily need to know this now, I'm just doing overkill. The output's like the dependent. But the book gives you some questions that kind of look like this, and they're saying, find the rule or find the function rule. Or like when they give you an x and a y. Or they'll say, here's a function rule. And what they're trying to say is this. If you have an x value, if you put it in here, that's going to tell you what this thing equals. It's kind of like they're saying y equals this equation there. But if I have this 4, 4 is like my x value. Do you agree I put my 4 right there for x? So I get 2 times 4 minus 1. And that's going to give an output of 7. If my input is a 2, if my x value is a 2, then I just take and put a 2 where x is. So I get 2 times 2 minus 1.
3.
3.
Oh my goodness, I wrote 3.
And if I put a 0 in as my input, 2 times 0 minus 1.
-1.
Negative 1. That's it. Questions?